Welcome to coding section. In this series, we'll be building a two-player fighting game in Flame. In this game, you'll be able to select your player and also the environment you'll be fighting in. You'll be able to fight against a computer-controlled opponent until one of the players win the game. I would like to note that knowledge of Flutter programming is a requirement for this series because I will not be going into the basics of Flutter and Dart programming, but I would focus more on the game development aspect. So without wasting any much of your time, let's get started. In this first video, I'll be covering some of the basics which are very important when you want to go into programming, especially in Flame, and some of them are the positioning and the anchoring. This might seem basic for those that are already conversant with building games in Flame, but as we go on in this series, we're going to have different layers with different components, and managing components can get very tricky once you don't understand these basics. So let's first talk about components. Component is anything that is added in the game. Think of them like Flutter widgets. They can be both visible and invisible. For instance, in Flutter we have rows and columns. These are not visible widgets, but they help to align things on the screen. So also in game development, some components might not be visible, but they play a major role in the background, like controlling how the players move. We'll see both of these components over the course of this video, so let's start building something. First, we'll create our Flutter project. This is the same as any Flutter project, we'll just create it using Flutter create. And when we have our project, we only need one library for this game, and that is the Flame library. So we'll go to pub.dev and search for Flame. It is usually at the top of the list. Within the web page, we'll see the link to the documentation. I strongly recommend going through the documentation because it has a lot of valuable information. In fact, with just the documentation, you are able to understand how it works to a large extent. If you can, it will be nice to go through it. Next, we add the library. And once we have it, let's go and clean some of this default code. The main entry point to any game in Flame is the GameWidget. The GameWidget is a Flutter widget which can be used in any parts of any Flutter app, just like any widget, and it requires this Flame game object. But the Flame game object is not a Flutter widget, it only runs within the GameWidget. So this is just something you need to keep in mind. Once we've set our Flame game object, which is called the fighting game, we'll have a black screen. This is because we don't have anything in the game. Before we add more details, let's look at two major functions used in Flame components, and that is the onLoad and the onUpdate. onLoad is called only once when the component is added to the screen, and onUpdate is called many times. For every frame in the game, the update is called to redraw the game components, and this is applicable to any game engine you might want to use in the future. We don't notice these individual frames because they operate fast, giving us the illusion of smooth movement. The onUpdate function is responsible for this. Within this function, you increase any variable you want to change, and they will change with every frame. So let's say you want to move forward, you just add a value in the forward direction, and as the game runs, it will update in every frame. I don't want to get too technical with this, but hopefully you get the idea, and as we move on in this series, it's going to get clearer and clearer. So let's create the first component. Within our onLoad function, I would add a rectangle component. This is just a rectangle with a size and color. We add this to the game using the add function, which the component as the parameter to the function. The rectangle component extends one important component we'll see continuously in this series, and that is called the position component. This component gives the object a position, a size, anchor, angle, and several other useful variables. Because it extends the position component, we can set the position using a vector2 object. This vector2 object holds both vertical and horizontal components as x and y values. So if we modify the x and y values, we'll see how it moves on both the horizontal and the vertical axis. Another important variable is the anchor. This is the part of the component that is pinned to that position. By default, all components are anchored at the top left, but if we anchor our rectangle at the top right, the position is still constant, but the part of the component that is fixed at that position now changes. And we can do the same by anchoring it at the top center, which changes where the rectangle shows on the screen. Another important variable is a scale. This is a vector2 variable that scales the object on both horizontal and vertical axes. You can use this to increase any component. Though this might not seem very useful with a rectangle now, which already has size, but working with other components and even images, you might want to increase the scale without tampering with any value within the component, and that is where scale comes in handy. We'll see it more during this series. Finally, let's look at the update function. I would like to update the position of the rectangle continuously, so let's make it accessible by other functions by moving it outside of the onLoad function. Then, within the update function, we can then update the values of the x-axis. By doing this, we can see that it slides horizontally on the screen. If we do the same on the y-axis, it also moves downwards. So any change we put in the update function is called whenever the frame updates. Updating changes with static values within the update function is not really recommended, because doing this would make the movement vary on different devices. A device with higher processing capacity is going to update faster than the one with slower processing capacity. So to account for this, we always multiply any update by delta time. This is the dt we see in the update function. So once we multiply our change by this value, we are always confident that it's going to be the same on every device. So let's clean up the code a little. I will create a variable for the speed and the size also. Then if the rectangle leaves the screen, we push it back to the top of the screen using an if condition. Note, we can get the size of the game from using the size variable. This is gotten from the Flame game class. Once I update this size with the correct size, then it works fine. In the next video, we'll start adding files for our game and working with sprites in Flame. So until then, have a nice day and please subscribe. Cheers.